Okay, so let's talk about the homework assignment. How did it go? Easy?
No, not very, not hard.
Piece of cake?
No, not at all. It costs like a moderate time. How many hours did it take? Actually, I would guess around 3 hours. Really? Took me twice, 6 hours.
Took you 6 hours?
Yeah.
How long did it take you guys?
7 to 8 hours.
7 to 8 hours?
Yeah, I was thinking a day.
A day? 24 hours total?
No, like not straight 24 hours. I mean, not straight.
So how many hours did you work on it?
Like 10 to 12.
10 to 12 hours? All right.
4 hours with my husband.
4 hours cheating? She cheated with her.
He helped me.
What does your husband do?
He's an IT professional.
Okay.
As a SharePoint developer.
Does he program?
Yeah.
Or neither of you program? You're just
No,
banging?
he's
All right. All right. But did you understand it in the end?
Yeah. I was doing it and he was just correcting my errors.
Okay. And how long?
Around 10 to 12 hours.
10 to 12 hours.
7 to 8 hours. Yep.
I haven't looked at this yet. I have to solve this in class, and it's what was the minimum? Minimum was, what did you say, 3?
I said 3. I think the most of the time cost is at the beginning I didn't have a way to display it. Then I just said, oh, I need to rewrite the toString function. And I think about it, how to write the toString function.
So otherwise it would have taken 15 minutes?
I would guess like 1 hour or so.
All right, so let's, first of all, remind me, what was the assignment? I think it was HugeInteger, right?
Yeah.
So you're supposed to be able to store arbitrary size numbers. So read something in as a string, and then turn it into a linked list representation, and then be able to add them together. Is that right?
I insert them both as a string list with that huge as much as you want to enter and then add them together.
What do you mean by huge?
Yeah, what do you mean by string list?
I mean, not as.
You mean it's a fragment of string?
Not string list, not linked list.
Linked list. Yep. Yeah, you're supposed to represent it as a linked list.
Yeah, not as a string.
All right. So idea is we read them in as a string or something like that, or we build our linked list using a string. That way we can easily get stuff in. But if you don't start it as a string, that's fine. But ultimately, if you had the number 128, it would be a 1 linked to a 2 linked to an 8, right? Okay. And so here, let me just make sure I understand what I asked you to do. Like I said, it's been a really, really long day. Well, I told you that last week. Wednesdays are really long.
Oh yeah, you said 11 hours of teaching.
Well, yeah, I mean, here, let's see. Let's look at this. Here's today's calendar. Wednesday. So this was Python I taught. This was operating systems. This was Swift for iPhone. This was Objective-C. This was Swift for Apple Watch. This was Swift for iPhone. This was an Apple Watch programming seminar I did for a place in New York. And then here's you guys. Here's you guys.
And actually before that, you also in Swift with that.
That's right. Yeah, I was doing Swift here. Hey. Hey. All right, so we called it what? HugeInteger?
Yeah, HugeInteger.
All right. So we're supposed to create linked lists. So like for instance, 123 plus 24, for example, is going to turn into a 1 linked to a 2 linked to a 3, something like that. And then the 4 will be a 2 linked to the 4. And then you're supposed to add these together, correct? Producing a final HugeInteger. So in this case, this is going to be 147. Like that.
Does it have to display like that, or if it just displays the total, it's enough?
Well, if you display the total, that's fine, but I'm definitely going to look to make sure you've done it with linked lists.
I have taken, I mean, I just put the,
Just the numbers.
just the number.
Yeah, me
It's
too.
just
I
the-
removed the arrows and make it just like a number.
Oh, that's fine, that's fine. So it is stored as a linked list. It just doesn't show the
it's
arrows.
Like 123 plus 124.
Yeah, all I care about is that you did store it as a linked list,
Yeah.
which then forced you to mechanically do the math
Yes.
with carries and stuff like that, right?
Actually, I have Windows system. I could not do that repository link. I downloaded that Git.
Git.
Yeah. I was not able to do that, the link. I downloaded that in the system installed, but it was not running. So I had some difficulty in
Okay. Well, so did you submit it?
I submitted the zip file.
Okay.
I couldn't get the link because every time I was doing the
Is it on your laptop?
Yeah.
You did it on your laptop?
Yeah.
All right. Well, at the break, we'll look at it. But that's fine for this one. But next time, don't wait till class to ask me. She asked me before class. Okay. Yeah, I mean, it's an important skill set. And I realize sometimes there's little quirks.
I don't know.
I
But-
think it's because they usually use PowerShell. Why they he can't grab the thing? He can't grab
He couldn't get it up to GitHub.
I would say maybe you should use PowerShell, not the CMD.
Oh, really?
Command line. Yeah, there is a Windows PowerShell.
Yeah, but that's not fun.
I don't know why, but when I found the solution, it is you have to use like you. Anyway, you search PowerShell in Windows and it'll give you another
Yep.
called command line. Actually, you can use Unix code in PowerShell, not in
I got you.
DOS command line mode.
All right, so let's start with this. We're going to start right in our HugeInteger thing here. So we'll go File, New Java project, and it was called HugeInteger. All right, and we'll go ahead and create a new class. We'll call this guy driver just to get the ball rolling. And so I like to repeat this every single time just so we get used to it. Public static void main, string array args. And then just to make sure everything's linking fine. All right, we'll go ahead and run this guy. So there's hello. We have a program that works, right? Okay, so now let's go ahead and build a HugeInteger class. All right, did I spell it right? HugeInteger. Okay, good. So a HugeInteger is going to be built using a string, but it's ultimately going to produce a linked list, correct? All right. So we're going to go ahead and we're going to create our constructor here. So public HugeInteger. This guy's going to take a string s as a parameter. All right. And we're going to have a linked list supporting our HugeInteger. So one of the things this guy is going to support is going to be a linked list. I'm actually going to rewrite our linked list here just for a review for us, because it's going to be a fairly simple linked list. So we'll go ahead and create a class called linked list. We're also going to create another class called node. All right, and a node is going to hold on to a private int payload, and a node is also going to hold on to a private node next node. All right. Then we're going to go ahead and have a constructor for our node. So public node, this guy will take in an int payload, and we'll set this dot payload equal to payload, like that. All right, so that's all node will do for right now. What's linked list? Linked list is going to be have a private.
Why you don't have the next node to now?
What?
What node?
In node?
Uh-huh.
Oh, you can. It's not a big deal.
Okay.
This dot next node is equal to null. All right, so now our linked list private node head public linked list takes no parameters. We set head equal to null. All right, so that is our empty list. So we're going to go ahead and evolve this as we start walking through here. When we build an integer, we're going to build it using a string. And from that string, we're going to generate a linked list. Okay? So that means as we're building it, we're going to constantly be adding. So if I'm going to walk through the string from the front, let's say, so if my string looks like this, 123, and I want to build this, I'm going to be adding to the end. Correct? If I walk my string from the end towards the front, I can add to the front. That makes sense? So I can choose which of those add methods I want to write. I can choose to write add front or add end depending on how I want to walk through my string. So do we have a preference? Do we want to write add front or add end? Do we want to walk through this string from beginning to end or from end to beginning?
I would say from display perspective, I would say.
All right, begin.
from end.
You want to do beginning? All right, we'll do the beginning. Okay. So that means we need to write add end. All right, so we'll go into our linked list. We're going to say public void add end. And this guy will take in a value. And how does add end work? Well, if head is equal to null, we just set head, we create the new node and set head equal to this, right? Otherwise, we need to walk to the end of the list. Okay, and that is until we find the node whose next node is null. And then we set that new node's next node equal to this guy. So we'll say node n is equal to new node value. So we'll go ahead and build that guy. Then we'll say if head is equal to nil, that's a true statement, then we'll go ahead and say head is equal to n.
Double F.
That's actually null in this language.
This is
Swift, it's nil.
the-
Okay. Else, if that's not the case, then we need to go ahead and walk to the end of the list. So we'll say cur node is equal to head, while cur node dot, we need to be able to get the next node. So we need to go ahead and give ourselves access to that. So I'll come in here real quick and we'll, we'll do source, generate getters and setters. And we'll go ahead and give ourselves the ability to get the payload. And we'll give ourselves the ability to get and set the next node. Good enough. All right, so we have those guys now. So back in linked list. So while cur node dot get next node is not equal to null, we'll say cur node dot, well, cur node is equal to cur node dot get next node. All right. So by the time that while loop is done, cur node should be sitting at the last node in our list, correct? So then what do we do with that? We say cur node dot set next node equal to n. That's the dude we just added. Okay. So this will add something to the end, right? Fair enough? All right, now let's go ahead and let's give ourselves the ability to display as well. And I'm going to display it with the arrows because that kind of gives us that feel that it's a linked list, okay? Unimportant whether you displayed it that way or not, but so we're going to teach our linked list, public void display. So we're going to say, we'll just say if head is equal to null, we'll say system.out.println empty list. Else, if head is not equal to null, then what we need to do is we need to go ahead and ask head to print itself, and then he asks each individual thing to print itself. So that means that we're going to go ahead and we're going to get, we're going to say public void display. So a node is going to know how to display itself, and what it'll say is system.out.print this.payload. Then we'll say if this.next node is not equal to null. So if we actually have a next node, then what will we do? We'll say system.out.print our little arrow dealy. Okay, and here we'll put some spaces on either side just for good measure, and then we'll say this dot next node dot display. All right, so that's the display method. Did you guys get the homework done?
Yeah.
How much time did you spend on it?
All the time.
All the time. So we took a poll. How many hours?
Like I completed in like 2 days.
2 days, and how many hours across those 2 days?
Like around 10 hours.
10 hours. All right, what about you?
14.
14 hours? That's it?
That's not all the time.
That's not all the minutes. Yeah, I joke with my wife. we have 2 cats left. We used to have 3 cats, but one of my cat is a lap cat. Her name's Gracie, and I tell her that my cat requires to be holdied, to be held. So I asked my wife when I get home, did you hold my kitty tonight? And she goes, yeah. And I said, well, how many of the minutes? And she says, I hold her for like an hour. And I said, well, how many of the minutes were you supposed to hold her? And the answer is all of the minutes. That's how many minutes she's supposed to get held. All of the minutes. All right. So far, Blade was 3 hours, right? And next in line was 6. Anybody beat 6? Oh, she had 4. That was 4 with help. Doesn't count. All right. So we only have 4 hours. How am I going to... Hey, am I going to be able to do this before class is over? I got more stuff to teach you. All right, got to focus. All right, so display. We'll ask a node to go ahead and display itself, and then if it has a next node, it'll draw in the arrow, and then tell the next node to display itself. All right, so then what will linked list do? Linked list is going to just tell, it'll say this dot head dot display, and that'll get the ball rolling, and then at the very end we can do a system.out.println, just kick it down a line because all those other guys were just prints. All right, so now our linked list knows how to display itself. Our node knows how to display itself. You have a question? You just following? Following? Okay. So now we go to HugeInteger. We have our string s. So what are we going to do? We're going to say for int I is equal to 0, I is less than s dot length I plus plus. So we'll spin through that string, and what are we going to do? Well, we're going to have to add it to our linked list for this particular HugeInteger. So that means our HugeInteger is going to need to keep track of a linked list. So we'll have a private linked list called the number. Fair enough. All right, and this guy will be equal to a new linked list, like that. All right, so then in here we want to go ahead and add the number to the end of the list, right? So in order to do that, what we have here is s.char_add_I is going to give us a character. I need to get that guy as a number. Okay, so what am I going to do? I'm going to say this dot the number dot add end. What am I adding to the end? I'm going to add integer dot parse int of double quote or empty string concatenated with s dot char_at_I. So this will get me the current character. This will turn that character into a string. We'll call integer.parseInt on that string, which will turn it into a number, and we'll add that number to the end of the list. Okay, then we'll go ahead and we're going to give our HugeInteger. Actually, here we'll just for practice here we'll say public string toString, and this guy will return this dot the number dot, ooh, that's not going to give us a string, so we're not going to do this. All right, so we're going to go ahead and we're just going to say public void display, and then we'll say this dot the number dot display. All right, so that should display it. Okay. So let's go ahead and test what we've done so far. So we'll go ahead out here. We'll create a couple of HugeIntegers. HugeInteger hi1 is equal to new HugeInteger. And what was our first number? 127? Yeah. And then we'll say HugeInteger hi2 is equal to new HugeInteger. What was the second number? 24. All right, then we'll say hi1 dot display hi2 dot display, and let's see if these guys look the way they're supposed to look. 127 and 24. So far, so good. All right, so now we have huge numbers, HugeIntegers. All right, was that it? Is that the whole homework assignment? All right, so now we got to add these dudes, right? We got to add 2 HugeIntegers to each other. So what does it mean to add a HugeInteger? All right, so our huge integers are going to look like this. And actually, let me start another drawing here. So we're going to create a text. So we have a 1 linked to a 2 linked to a, what was it, 27? Is that it? Nope, 23. You're wrong. Except, wait, hold on. What was it out here? Ah, it was a 27. Let's change it to a 3 so they all match up. All right, so we have that. And then we have, what was the next one, 23?
24.
24. Told you, I'm out of it, people.
You are old.
23 there, 24 there. What was this one? Oh, 24. So wait, you're out of it. 24? There we go. All right, so we have two huge integers like this. And what we need to do to add these together, we need to start at the end of our numbers, right?
Yeah.
Okay, and do what with them? We need to take the last number, add those guys together, and add it to a new number. Correct? So we're going to be building up a new number, but we need to keep track of our carry bit. All right, so 7 plus 4 is 11. So that's actually a 1 carry a 1. That makes sense? Okay. So let's start with kind of the simple case, and then we'll kind of look at things that break. So inside of huge integer, we need to go ahead and keep track of, well, we'll add it up there in a few minutes. So let's create a public huge integer add. This guy's going to take a huge integer as a parameter. Okay, what we're going to do is we're going to add this huge integer to hi, resulting in a brand new huge integer. Okay, so we need to go ahead and give ourselves a brand new huge integer that's empty. All right, something that we can build onto. So we'll say huge integer answer is equal to new huge integer empty string, like that. So now we kind of have a blank slate for building up our answer in, right? All right, now when we add things to our huge integer, this guy, we're going to be adding, so let's give ourselves a blank slate for our answer. So our answer here is going to start off looking like that. Then we're going to have a 1, and we're going to have a carry over here. So carry will start off as 0. So 7 plus 4 plus carry is 11. Okay, that is 1 with a carry of 1. All right, so right now, my answer looks like this. Then I move in one level. So I say, this guy plus carry plus this guy is 4, 5. And where am I adding that to? I'm adding it to the front of my linked list, right? Okay, adding it to my front of my linked list. I want it to come before the 1 instead of after the 1. So I need it to look like this. Okay? And carry then becomes 0. All right, so before we go any farther, we need to go right add front. Okay?
And remove it.
Okay, so we'll go ahead and right add front. So we'll go into linked list. There's add end. So now let's write public void add front int value node n is equal to new node value if head is equal to null, head is equal to n. Else we're going to say n dot set next node to head dot get next node, and then we can say head is equal to n, like that. Make sense? All right, so now we should be able to add stuff to the front of our list. So let's kind of mess around with that now. Oh, of course.
Did you make this problem in the rest of the class?
I haven't had this problem once today.
So it must be wrong with the PowerPoint. How about create a new one?
Let's well, I'm gonna click on share after this finishes crashing.
Yeah. It's annoying.
This is cutting into my time. I only have 4 hours to do this.
Now you have plenty of time.
Really?
If you stop joking.
No, that's a fair question.
This is the most of how you want part, right?
If it doesn't, just leave the class.
How about keep on writing remove and
So let's stop sharing this.
okay.
Start with that. Then let's close Keynote, reopen it, reshare it. Close Keynote. Oh, I didn't actually close Keynote. Now I've closed Keynote. Now we'll reopen Keynote. And then we will, well, I can just do it down there. Open recent. Oh, so good.
You were just
Then we'll share it again. Oh, perfect. Can't manage those settings right now. Whatever. We'll reshare it later after it's calmed down. All right. Oh, perfect. I reopened it, didn't I? Oh, good. It must be, we'll let it rest for a few minutes for the keynote. Come back to that. All right, so in any case, we now have add front that'll add stuff onto the front of the list. Let's just quickly test that to keep ourselves sane. So inside of HugeInteger, let me just comment this out real quick. Actually, let's just do this.
You just add a return.
So I'll just do return null for right now. And then I'm going to come in here. We're just going to say answer.add. Oh, that's adding that thing in there. So we'll just do this real quick. Linked list LL is equal to new linked list. And then we'll say LL.add front 1, LL.add front 2, LL.display. Good enough. Let's just make sure two things pop up there. So we'll go ahead and say hi1.add hi2.
Actually, it's not related.
And there's our oh.
No.
That's the one.
So we added 1, then we added 2.
So you don't, it just display 2.
Add front. Oh, I think that's our display method is what's broken. I think it does add things to the front, because if I change this to this.
Why you cannot access to
Boom, boom, boom. Oh,
okay, just display the last one.
and our add front is broken.
Yeah.
Moment. Okay, add front takes in a value. We build the node around that value. If head is equal to null, then we make head is equal to n. Fine. Otherwise, we set n. Oh, this is it. We set n's next node equal to head, and then we set head equal to n. This fixes it. All right, so we had a bug in our code. I was testing you. You all failed. Okay, so now that we've tested that, we know that works. Let's get rid of this junk. So down here at the bottom, we will do a return answer when all is said and done. Okay, so now what we need to do is we need to walk our two huge numbers from end to beginning, adding them together. Okay, now a couple things we need to keep track of. is there is no guarantee that our huge integers will be the same length. No guarantee they'll be the same length, right? Okay, so a couple of things we can do here. We can figure out which one's longer. We can pad the other one. Okay, that's one thing we can do. We can just go ahead and write it with it in mind that we might not have a value at that position. Okay? So several different ways we can do it. Which way do we want to do it? Do we want to guarantee that our two numbers are the same length?
No.
Okay, do we want to just leave them the length they currently are and walk from the end towards the beginning?
Why don't we add zeros to the short number to make them both the same length?
Well, isn't that what I just said?
Yeah.
So that you want to guarantee that they're the same length.
I don't think so. We need it. Actually, we can because
You don't want to do that.
I don't do it.
All right.
I thought about they're both the same length. One has 20, one has 50.
They're not very
Well, you can. You just have to ask some questions, right?
Mhm.
All right. So let's go ahead and let's walk this. So why don't we start with the simple case?
Okay.
Simple case being they are the same length.
Equal.
Yeah.
Okay. So let's write it that way. Oh, I don't have my keynote open yet. That's fine. Should we give it another shot?
Fine.
So I like drawing pictures with my keynote. Okay, so let's go ahead. Well, you know what? We don't even need to do it in the simple case. Let's just do this. All right, so we have our two numbers. This is hi1, this is hi2. So let's just label those. hi1, hi2. All right, so we need to start adding these numbers together, which means that we need to be able to access the last element of these values, or the element at a given position. Make sense? All right, so would it be helpful to know how many elements are in our huge integer?
Yes.
All right, so that's going to be easy enough. So we can go into our huge integer class, and now we'll do it in linked list, right? So linked list is going to have a count, so we'll have a private int count. By default, count is 0. Every single time we add something, we'll say count plus plus, whether we're adding it there or we're adding it here. In either case, it's always going to be count plus plus. All right, then we're going to go ahead and give ourselves access to that count variable. So here, I'll just generate getters and setters, and we want to have for count a get count. All right, so now we have that guy. So we know how many elements are in our list. All right, so we know that we're going to have to go through whichever our two numbers is larger number of times, right?
Yes.
Okay, so we want to figure out which of our numbers is bigger. Okay, so let's start off here. We're going to have a huge integer, big num. Okay, and this guy is going to, let's start him off being equal to the number that was passed in, hi. So we have a big num and hi both point to the same place. Okay, now we're going to ask the question, if this guy actually is the longer number, we're going to have big num point to him. Okay, so by default, we're going to do this. We're going to say big num is equal to that, huge integer, small num is equal to this. This guy is a big num. There's a big integer, right? Or a huge integer. This guy's a huge integer. So small num by default will be this guy. Big num by default will be the guy that was passed in. Now we're going to ask the question, did we guess wrong? Are they actually flipped around? Okay? So we'll say if big num dot we need to be able to get the size of a number. So we'll do this in HugeInteger. So we'll say public int, we'll call this guy size. And this guy will return this dot the number dot get count. Okay, so we'll say if big num dot size is less than small num dot size, then we got it wrong, right? And what do we do then? We're going to say big num is equal to this, and small num is equal to high. So we'll switch them. All right, so when we get right here, we know that big num is the bigger of the two numbers, and small num at the very least is, well, at its biggest is the same size as big num. Okay, no more than big num. All right, so now we know that the maximum number of digits we're going to have to walk is big num dot size number of digits. Okay, that's the number of little math problems we're going to have to do. Okay, so having said that, we need to now give ourselves access to a certain element of a huge integer, right? So give me element at bucket whatever. Okay, we know how many buckets there are now. There's size number of buckets. So let's go ahead into our linked list and let's give ourselves a public int get at index, and this guy will take an int index. Okay, and we're going to go ahead and we can assume that our index is a legal position in our string. We don't need, or in our list. We don't need to error check it. All right, so we know we're going to have a node, cur node is equal to head. For int I is equal to 0, I is less than index, I plus plus, we'll say cur node is equal to cur node dot get next node. Okay, then in the end, we're going to say return cur node dot get payload. That'll get us that number. Okay, so get it index is going to say, go ahead and give me the value at bucket 0, value at bucket 1, value at bucket 2, and it'll go and grab the correct node and then yank the payload out of it, handing us the payload as an int. Okay, so let's go ahead and test this. So inside of HugeInteger, now that we know which number is the big number, let's just write a quick little for loop for int I is equal to 0, I is less than big num dot size, I plus plus, and then each time through, let's just do a system.out.println, and we want to go ahead and get big num's value at a certain position. Right now, big num doesn't have a way of giving us the value at a certain position, but it knows how to get a value at a certain position. So we just wrote it inside of linked list right here. So now we need to go into HugeInteger and we need to say public int get digit, it's called int index, and we'll return this dot the number dot get at index index. All right, so we just taught huge integers how to give us one of their digits, and they give us their digit in terms of their underlying linked list. Okay, linked list knows how to give us bucket 4, so we can ask the huge integer to give us bucket 4, and he'll hand us bucket 4 from the linked list. Okay, so what am I going to do in here? I'm going to print out big num dot get digit I. So in our case right now, the big num should be 123, right? So this should print out bucket 0, which is 1, 2, then 3 on separate lines. So there's the 1, 2, 3 separate lines. Okay, so far so good. Okay, so now we're able to extract individual digits. Fair enough. Okay, so we're going to go ahead and grab those. Now, what happens if I ask big num for bucket 3, and I ask small num for bucket 3, and one of them, well, actually in this case we'd only have bucket 2, right? So I ask big num for bucket 2, and I ask small num for bucket 2. Small num does not have a bucket 2. What would I get? Right now I wouldn't. Right now I get a, it would give me an error. Because it would give me a null pointer exception, right? Okay, so I need to, if I'm gonna do that this way, I need to be able to handle that. Okay? So what we're gonna do is we know that the problem will not happen on big num. We know that big num will always give us a digit because our loop is based on the length of big num. Okay? Our risk is on small num. Small num might be shorter than big num, and if it is, we might ask for a digit from it, and it might not have one to give us. Okay, so we're gonna have to do a try and catch to fix that since we didn't pad it. All right, so in order to do our math here, what we're going to do is we're going to go ahead and we need to be able to append digits onto huge integers. Okay, now one thing we could have done is you could have actually built up your solution inside of a string, but strings do have a maximum limit. So that's why we're going to do it inside of huge integers directly. So we need to now have the ability to append values onto the front of a huge integer. Huge integers can do it in terms of linked list, but we don't have a way of telling a huge integer, go ahead and toss this digit on the front of yourself. Okay, so we're going to add to huge integer public. Actually, we could make this guy private since we're currently inside huge integer. So we're going to say private void append to front. Is that right? We'll always be appending to the front. Think about that. So first it'll be a 1, then we're appending onto the front of that the 5, appending onto the front of, yep, so it's always append front. So append front, this guy will take an int digit, and what will we do with this? We'll say this dot the number dot add front digit. All right, so that'll allow us to append a value onto the front of a huge integer. All right, so down here, as we're going through our numbers, we're going to do some math. All right, so let's just give ourselves a couple of integers. So we'll say int num1, int num2, and then we're going to have an int carry, and carry will start off at 0. Okay, so we'll go ahead and we will get num1. So num1 is going to be equal to get digit I from big num. Num2 is going to be equal to small num dot get digit I. Now this line could have a problem. All right, this line could have a problem. Now, what we can go ahead and do though is we can go ahead and add carry onto num1. We know every single time we're going to have to add the current value of our carry. When I do this, when I say 7 plus 4, I'm actually saying 7 plus 4 plus 0.
Yeah.
So if this is num1, 7, can't I say 7 plus 0 plus maybe 4? Okay, maybe 4, because when we do get to here, I'm going to say 1 plus 0 plus, oops. Okay, there's no value there, so I have to be able to handle that. Okay, so what are we going to do? We're going to say this. We're going to say num1 is equal to this value plus carry right off the bat. Okay, let's go ahead and add the first digit, which we know will be there. We'll go ahead and add the carry to that guy. It's going to get thrown into the sum anyways. Then we're going to try to get num2. And we'll catch an exception. Okay? If something bad happens, we'll catch that exception. So now, if we try to get num2 and we successfully get num2, we can go ahead and finish our math. Right? What does the math say? Math says, okay, well, we're going to go ahead and we're going to say, let's create a sum here, int sum. So we'll say sum is equal to num1 plus num2. That's our sum. All right. Catch the exception, sum is actually just equal to num2. I'm sorry, num1. Num1 already has carry in it. Num1 already has carry in it.
But why we have to use try catch? Why not just use if statement? There's no reason. If the I is larger than small long, the length of small long is larger than I, then it will be they don't add number 2. That's right. That's already.
Only 2 if you don't add number 2.
Well,
I mean just use this.
so you could do an if statement saying if
Yeah.
I'm at a digit here that shouldn't exist, then we can stop. Otherwise, we could just always apply the exact same algorithm and say, I'm always going to try to grab a number. If it works, great. If it doesn't, that's okay too. Okay, so I think this one gives us the easier logic than having a bunch of if statements in there. So, this guy's going to say, look, I'm going to always get the first number and add the carry to it. I'm going to go ahead and try to get the second number. If it's there, it's there. If it's not, it's not. If it's there, I'll go ahead and use it. If it's not there, I won't use it. Okay, that's the punchline, right?
That is means you don't need to think about it.
Yep. So when I get to right here, I know that sum holds my sum. However I came to that sum. It doesn't matter how I got to it, it holds it. Make sense? All right, so now at this point, I just have to ask myself, if sum is greater than 10, I'm going to have a new carry next time, right? New carry next time. So if sum is greater than 10, then can sum ever be greater than 20?
No.
Oh, so the most carry can ever be is a 1. Carry is always either a 0 or it's a 1. Okay, so if sum is greater than 10, I can go ahead and say carry is equal to 1 and sum minus equals 10. Okay, else carry is equal to 0. And we leave sum alone. Okay, so after that little if statement there, we know that carry has the right value that we'll need next time. All right, and we know that sum has the right value we need right now. And what do we do with that sum value? We say answer dot append to front what sum. Make sense? All right, and we're going to keep doing this over and over and over again until we run out of big num size. Now, when we get past the end of this loop here, though, before we can return answer, we need to check the final value of carry. Because if carry still has a 1 in it, that means I have one extra dude I have to add on, right? So if carry is equal to a 1, then we can go ahead and say answer dot append to front carry. And then return the answer. Okay, so if my two numbers are 127 and 124, I should get a 1, then a 5, then a 1, 151 like that. Let's see if that's what goes down. So we get our answer here, so that guy's going to actually be a huge integer, so let's just tell that guy to display himself. 363, that doesn't look right. Okay, so now let's walk through and see what happened.
For an index, it's counting from the head. Actually, we should count from the end, or just.
So in our linked list here, when we said get at index, we viewed our linked list as being in order, right? We actually are walking our strings from the end towards the beginning, right? Okay, so we either need to invert our numbers or we have to walk them backwards, okay? So really what we want to do here is inside of HugeInteger, when we do length, we're not going to start off at I as 0. Hold on, we are going to start off at I as 0 there. We're not going to start off at I as 0 here and add. We're going to start off as I is equal to big num dot size minus 1. Big num dot size minus 1. We're going to keep going as long as I is greater than or equal to 0. And we're going to subtract 1 from I each time. Wait a minute. Still gives us the wrong answer. What's going on? Let's go ahead and print out our nums each time through here. All right, so I'm going to go ahead and I'm going to print out, just for the sake of argument here, let's take the carry off of this. And let's do system.out.print. Actually, you know what? Let me do this. I'll show you guys how to use the debugger in case you haven't seen it before. So I'm going to go ahead and I'm going to run this through the debugger. So I'll click this little bug looking dude here. Okay, but in order to do that, I'm going to go ahead and I'm going to start, toggle our breakpoint there. So I right clicked right here. This will run my program up to this line right here. All right, so I'll go ahead and hit the bug. It takes me in here. The kind of launch is configured to open the debug perspective. Yes, that's what I want. Okay, so this gives us kind of a different perspective for this. So it stopped our code right here. All right, and I can look at the current value of some different things. So let's go ahead and step over this. Where's my step over controls? Up, down. Oh, here they are. Here they are. Yeah, thank you. All right, so we want to go ahead and step over. So we'll step over that line. And so we can start seeing the values that we have over here. So here's this. This is the number. Number has head. Head points to a node, so its payload for head is 1. Next node should point to a 2, whose payload is 2. Next node should point to a 3, payload is 3, whose next node is null. All right, so this seems like it's the correct thing, 123. The other guy should be as well, so let's step over this. Okay, so now we have small num. Okay, we actually do need to reverse them here, right? All right, so after we're done with this, what do we have? We have big num and small nums. We need to make sure that big num is our 123. Okay, so here's head. Payload is 1, 2, 3. So that's our 123. And then let's make sure that small num is also the smaller number, just to make sure everything is correct. So that's the number 2, followed by the number 4. Okay, so big num, small num seem to be the right values. Fair enough. So now let's go ahead and step over this. Okay, so now we're going to go ahead and we're going to start I off at big num dot size minus 1. Keep going as long as I is greater than or equal to 0. Subtract 1 from I each time. So we step in here. We're going to go ahead and get num1. So I'm going to stop right there. Here's num1. Num1 is a 3. That is this digit right here. Right? Sound good? All right, so we got our 3. Okay, so now we're going to go ahead and step over again. We had we tried to access bucket 2, but there is no bucket 2 here. Row. So what do we do?
We should either write the get index from the backend, or we can just add another loop for number 2. My way of doing it is just to pop out the last digit. That's easier. Not to think about it.
Well, so 3 plus 0 should give us what? 3. But we really need it to be adding to 4.
Yes.
All right. So we could start at the end of both numbers,
Yes.
right? So we could say, well, the last legal bucket in big num is big num dot size minus 1. The last legal bucket in small num is small num dot size minus 1. Keep going until they are, well, we know big num will go down to 0. But if small num ever becomes -1, so this goes back to your if statement thing, right? Okay, but the if statement wouldn't allow me to show this. All right, so now we can ask, if it's an illegal position, ignore it. All right, so we see what the problem is now. We're trying to access bucket, this is 0, 1, 2 of this guy, and there is no bucket 2 of this guy. So we're saying 3 plus 0 gives us 3, instead of 3 plus 4 gives us 7. Okay, so let's go ahead and stop this. Take us back to the original perspective. It should take us back to the original perspective. Oh,
Yeah.
Java there. All right, so now let's rethink how our loop is working for our add.
I think we can rewrite the get digit from, you can say get the last digit, or get from the end. I mean, the bucket 1, bucket 0 can be the last one, and
Yeah.
you become the last second. So we can get the last digits.
You can, except then you'd have to write a doubly linked list to walk backwards.
Oh, that's
Or you'd have to have a lot of, you
that is
verbosely
true.
always run all the way to
That
the
is
end.
true.
This will be better. All right. So we have num1, num2. Now what we're going to have is int pos1 is equal to big num. Actually, let's call it this. Let's call it big pos is equal to big num dot size minus 1. That's the last legal position in big num. Int small pos is equal to small num dot size minus 1. Okay, that's the last legal position in small pos. Okay, so now what are we going to do? Well, we know how many times we're going to go through here. We're going to go through this number of times. That's a fact. All right, each time through we can go ahead and grab num1 and go ahead and add in the carry. Okay, but now we only want to do this if num2 is greater than or equal to 0. I'm sorry, not num2. If small pos. If small pos is greater than or equal to 0, then let's go ahead and grab small pos. That is, we're not going to use I here, although we could use I there for num1. In fact, we probably should, but we'll use big pos. They're going to mean the same thing. Okay, so we'll go ahead and grab big num, get digit, big pos. We'll grab small num dot get digit, small pos. So, but we're only going to do that if small pos is greater than or equal to 0. Otherwise, we don't need to touch. Actually, we can do this. We could say we'll just do it in else. Be cleaner. Else sum is equal to num1. Good enough for us right here. All right. So what are we doing here? We know this is the number of times we're going to go through. And at this point, it doesn't matter if we start this off at 0. You know, we can rewrite it the old way. So we can say I is equal to 0. I is less than big num dot size I plus plus. We're going to go through this loop the same number of times because we're not actually using I anymore.
Yes.
Now we're using small pos and big pos. That's the guy that's actually doing the work for us, right? All right, so what are we going to do first? We're going to go ahead and get num1 at position big pos. That will always work, 100% of the time. Then, as long as small pos is a real number, let's go ahead and grab small num at bucket small pos. Tack that onto my sum. Now, if it wasn't a real number, let's just set num1, or set sum equal to the current num1, and then do the same logic as we had before. Now, we do need to remember, though, that after we've done whatever we're going to do, we have to say big pos minus minus and small pos minus minus. Even if small pos was illegal, subtracting 1 from it's not going to make it any bigger or greater than 0 anyway. So we'll still keep failing right here. That guy will keep failing. If it was already a -3 and we just made it a -4, it's still not bigger than, greater than or equal to 0. Okay? So we'll use small pos and big pos to figure out where we are in there. We'll still ask the same question we had before. Still append our answer. 147?
Correct.
Ooh.
It's not the same.
What do I have?
That is 1, 2, 3, not 1, 2, 7.
What do I have here? My
Right.
oh. There we go. 151. All right, so now let's get something that does overflow. So we make sure we get the extra digit. So if we say 199 plus
9 to
199 plus 24, so we'll have an overflow there.
have 8 or 9.
We'll have an overflow there.
It won't exaggerate. It should have 3 digits for the second one.
All right, so we need this to be, let's say this is 599 and this is 603.
Okay. Oh. What does this come? So
All right, so 9 plus 3 is 13.
12.
Oh, 12, thank you. Okay, 9 plus 3 is 12. 12 is greater than 10,
That's
Plus
the first
9.
2, yeah.
so that gives us the 2.
There, yeah.
It gives us the 2 with carry the 1. Then we have 9 plus 1 is 10.
Now we have another one. 10.
Okay, so so we have 9 plus 1 is 10. 10 plus 0 is
10.
10 is, let's see what our if statement asks. I think we only asked if it's greater than
Yeah,
or equal. We are asking if it's greater than 10. It needs to be greater than or equal to 10.
Yeah.
If sum is greater than or equal to 10. There we go. 1202.
Right.
All right. So I think that probably solves it. All right. Questions about that? Now, maybe a couple things to pay attention to what we did there is notice that I didn't necessarily start off with a generic linked list. Okay? I didn't start with a completely generic linked list. What did I do? I kind of grew our special purpose linked list for what we actually needed for the assignment. Does that make sense? Now, should you always do that? This becomes an interesting problem-solving question. And this is, so last time I kind of harped on the fact that I want you to make sure you do your assignments using only what I've shown you, right? Okay? We're all like MacGyver. We got to solve the problems in terms of the tools we have available to us, and there's a reason for that. But now we want to critically think about this problem. Is what we did here professionally smart? It's what you had to do for the assignment because I said you got to write your own linked list. So you could have either used the linked list we wrote in class last time and just, it had, the 30 features of which we needed 3 of them, right? However many things we wrote. But, the linked list we wrote in class last time was more capable than what we actually needed for this assignment, correct? We only needed a couple of the abilities. All that add and remove an index stuff, while fun to write in class last time, wasn't necessary for this assignment. Yeah. Okay? So, was it good for us to write a smaller version of our linked list here to solve this specific problem? Or was it smarter to just use the linked list you already had? And why?
For working perspective, I read the natural set most of the time just to use the one list, because if it's used for public, I mean there's a public library. It means at least there's less bugger than who write it on their own.
Okay, I'm saying given our situation here though. Our situation is you were provided with essentially a linked list that worked, right? That did 10 things. You actually needed a linked list that worked that only did 3 things. Okay. You had this, you needed this. Do you just use this because it works and go to town with it? Or do you rewrite it so that it only has the features in it that you need?
I'll do that.
Use the one that already works? Okay.
As per the requirement, I think that one's good. The other one.
The original one?
No, the next one.
Okay.
Rewrite.
But that took time to write.
Oh yeah. But still, as per the requirement, professionally that would be greater than.
Okay. Why? In what cases would it be greater? This is what we want to think about from IT
For
people.
embedded system, if you have limited space for storage, then you have to write your own. Otherwise, you have enough space.
Okay.
Actually use the one.
If space is an issue, if having that smaller file size, because we wrote a linked list that did less stuff, if that was important to us, okay, if that was going to make a difference in our lives, okay, make a difference for the final solution in terms of its viability, yeah, then you write something smaller. You write something perfect for the solution, right? Okay. But most of the time, is that going to be the case? Or is most of the time you're looking for an accurate solution that works in as short of a period of time as you can produce it,
Yes.
right? You know, we're in a little bit of a weird situation here because we're still practicing, right? We need to drill this stuff and get good at it and that kind of stuff. But in the big scheme of things, if you have a tool sitting right here, so let's say we're at the house and we're going to make smoothies, all right? And I already have a blender, okay? But I'm only going to make small smoothies, okay? Little small smoothies, okay? But I got this giant blender made for like the big margarita bar, right? Okay, you know what I'm saying. All right. So do I go out to Target and buy the smaller blender for my smoothies, or do I just use the big blender and put less stuff in it?
Bigger one.
I use the bigger blender, put less stuff in it, right? Makes sense. All right. So most of the time, if we have a tool that already works, we want to leverage that for our solution, right? Okay. So questions about this assignment?
Yeah, for my solution, if I just say pop out the last one, is it quicker than your get at the index?
Okay, so you actually removed the last element?
Yeah. Is it less quicker or cost less resource? I think like it's the same.
So you did it. You implemented it as a stack. So you popped off the end.
No, I just used the remove last.
So you did remove last.
Yeah.
Okay. So each time were you having to walk all the way to the end? Okay. So if each time you called remove last, you were walking all the way to the end. It should functionally be the same.
Yeah, I think.
Because I'm walking all the way to the end as well each time by saying get digit at index. So at the very least within one or two orders or something like that. It should be the same. Okay, so.
Can you upload the code for us?
No, I'm going to delete it right now.
It's go.
Go!
All right, so let's just review here how to do the GitHub stuff. All right, so I'll create a new repository. This is going to be CSC, what class is this? 537, fall 2015, HugeInteger. Okay, so that gets me to this guy.
Professor, every time we use this, do we have to follow the steps that you have told us, or?
Well, every single time you create a new repository, you do. If you're pushing to the, like when I'm in some of my other classes and we're making a constant update to a repository, I don't have to follow all these steps. I just have to push the new version. It just automatically pushes the update to the cloud. All right, so I'm going to go ahead and I need to move into that directory. Where am I sitting here? All right, so now we're sitting in the right place where we see all of our, wait, hold on, this isn't it. HugeInteger, CD HugeInteger, there we go. All right, so we're sitting in the directory with all of our .java files. So the first thing we do is we do a git init that creates the git repository. So if we do ls-a, we'll see the .git thing that's there. Then we'll do a git add star.java that adds all the things to the repository to be tracked. So if I do a git status, we'll see that we have 4 new files that have been added to the repository. Now I need to commit them to the repository, so I'll say git commit -m, and I usually just say initial commit. All right, so that adds it to the repository. If I do a git status now, it shows me nothing to commit, working directory is clean, because the repository matches the current state of my code. Okay, so now, as far as the local Git is concerned, I'm done. I've committed my changes. It's keeping track of all those things, blah, blah, blah. But now I need to get it up to GitHub. So I go into GitHub here. I just steal this last line, no, second to last line. I only have to do this one time. I'm just letting this particular repository know that I want him to be linked to a remote repository. Okay, and this is the address of it. So I'll steal this guy here, paste that in. All right, so now that just created a local variable. I only ever have to do that once. Now every single time I ever want to make a change to the cloud after I've committed locally, I just have to do a git push -u origin master. And that'll push it up to the cloud. So now here is the code. Make sense? Okay. Now let's see. I believe, invite everybody to Slack, didn't I? Okay. So I'm actually going to paste that in Slack so you have it there. So if you're not already on Slack, I put the instructions up there, didn't I?
Yeah.
How many of you actually signed up for it?
But I'm not in the channel, I think.
Yeah, see, we do a lot of stuff in computers. I mean, so this is all a private message. I won't open those in case there's something interesting in there. But this is a really good way for you guys to connect with the computer science department, okay, especially our undergraduates. And I think I mentioned this to you last time, and I'll actually say something kind of interesting coming up as well. So first of all, how many of you are aware that we're getting ready to offer a Master's of Computer Science? Okay, Blade knows about that. So right now, most of you are in MSIT, right? Because that's all we had. Okay, starting in the spring, we're going to be starting our Master's of Computer Science degree. Okay, so if you are interested in more of the computer science, writing lots of software, that being your job description side of things, you might talk to Dr. Locklear about that program and how we can transition you into that program if possible. Kind of trying to count some of the stuff you've already taken so that you don't fall behind or something like that, if that's more of a good fit for you. This is the first time we're offering it. So we're going to have two separate tracks. So CS as well as MSIT. If you're already most of the way done with MSIT, it might not make sense to go back and switch. I don't know. I don't know what we can pull off. But in any case, I just wanted you to be aware that that's there. But I'll also say, and I don't remember if I mentioned it last time or not, but there's really good value for both sides for you guys to work with the undergraduate students. All right, in all sorts of stuff, like so I keep using Blade as an example. Every single morning at 7:30, we meet in the cafeteria. So it's me, him, one of our seniors in computer science, a guy who's a junior in the business school, and a couple other computer science majors are involved in various projects. Having that collaboration is really important, not just for you, but also for them. Okay, a majority of our master's program, as we talked about last time, are international students, right? Or all our undergrads are a majority are Wisconsin folk. Okay, they're not used to working with international people. Okay, so you're going to run into multicultural people in industry all over the place. So it's going to benefit them working with somebody who is from a different culture, right? It's also going to benefit you guys being forced to deal with somebody in English all the time, right? Because what ends up happening is, I see it all the time, you guys form your little clusters, okay? And your clusters are formed with other people who speak the same language as you speak, okay? And so instead of practicing the thing that you're weak in, you fall back to your comfort zone and you're, talking in your native language, right? Who wouldn't? Okay? So if you're forced to be outside of your comfort zone and work on this stuff, it's just going to make you better. All right? So using our Slack tool here is actually going to be a good starting point. Get involved in some of the conversations. I mean, this has all of our students in it inside of General. So as an example, yeah, this was a funny thing. So we'll put that in there. Okay, actually a famous guy here, Linus Torvalds. You guys heard of him before? Yeah. Okay, he's the kind of the inventor of Linux. Okay, inventor of Linux. Getting a little bit older now, but he was actually talking about this interesting rant thing. They pretty much censor all the bad words. They put little asterisks where it's really bad. But the other day somebody tried to commit, and this was the reason I thought of this. It involves GitHub. So Linux is managed on GitHub, and somebody tried to commit a change to something in the Linux kernel to GitHub. that had really bad programming. You can read it and see it. So Linus Torvalds goes off on these people how this is terrible programming and you should never write this stuff. You should be afraid to look yourself in the mirror and all this stuff. But in any case, it's it's a good opportunity to kind of connect with our our undergraduates as well, and also share some of your experiences with them. So I would encourage you. Yeah, so goats, there's some backstories to a couple of these things. So I would encourage you not just to get involved on the 537 channel as you're working your homework or asking questions or something like that, but hey, go on to the general channel and introduce yourself. Say, hey, here's my name, I'm in the MSIT program, here's the things I'm interested in. Let me know if you guys ever want to get together and do something, whether it's work on some project. If you have a project idea and you're looking for some undergraduates to work with, you're just interested in movies and you want to go see if somebody wants to go to the movies, it'll benefit you to get connected with our undergraduate students, because something that ends up happening with international students is they become isolated, right? You come over here and you're just treated as the dumb foreigners that don't know any better, and it's very much a segregated community where computer science nerds are segregated by definition. So you might as well be segregated together, right? So I'd encourage you to get involved with this. It's actually a good tool, and our undergrads use it a lot. I use it for all of my classes. So if you have questions to ask me, if it's a question about your homework specifically or something like that, I'd encourage you to send me a private message on here. If it's a question about homework in general or something that you think would benefit the class, go ahead and put it out in the public channel for 537. Say, hey, I'm working on my homework. Here's the line of code that I'm having problems with. I don't know why it's producing this. Paste it there. I'll probably turn around and answer it, but if anybody else in here can help answer it, go for it. Okay, so get used to doing these collaborative things. It'll make you better. Okay. The other nice thing about Slack, some of you have already run into this in industry. If you're working out in industry, is Slack is actually commonly used in industry now for a group communication tool. All right, so I'm in multiple Slack groups, so this is I only have a couple of them set up on here. So this is for computer science. This is for the company I mentor for out in New York. There's also a student version of this, and then we have another one for CU Launch. So I'm in 4 different Slack channels, and there's an app for Mac, PC, iPhone, Android, bathtubs. There's basically an app for everything. So Slack is really easy, so you get your push notifications on your phone just like it's a text message. All right, so get involved with that. I highly, highly, highly encourage it. Okay, so let's talk about what comes next. So let's go back to our original linked list here. Let's just close all of these guys, and let's go back into linked list. Well, let's see. Does our current linked list do everything it's supposed to do? All right, so I add front, I remove front, I add end, I remove end, I added index, I don't remove an index yet, right? So let's go ahead and write remove at index. But then what we want to do is we want to start thinking about some of the weaknesses of our linked list. So just to kind of get us warmed up, as if we're not warmed up enough, right? So we'll go ahead and
I think we have already.
we're warmed up. We just got started. Can't believe that took you 14 hours to do that assignment. It's terrible.
So how many hours did you take for you to finish it for your first time?
I just did it my first time. You watched. That was the first time.
No, this is not your first.
Well, that exact problem it was.
Okay, I trust you.
Otherwise, it's not fun for me. It's tough sitting up here for 4 straight hours. I have to give myself some sort of challenge. Otherwise, I'm just going through
Can you say what the last time you teach this class and the assignment for linked list, what they did?
Let's see. It would have been last fall. What was? We could probably look it up. Oh, and that was on Angel. I can't look it up. It's a good question. I don't know what it was. Sometimes I do like a merge sort with lists. So it could have been that.
Because I think this is quite a good example for trying to practice with linked list.
It's possible I asked something like this
I
before.
thought you use it over and over again.
I mean, I think I've asked a question like this before. Maybe in the past I've maybe done subtraction or something like that. I don't remember now. At the very least, I don't remember doing it before. But then again, I don't remember yesterday. So
I told you you're an old man.
so I am an old man. It's terrible.
Bad memory.
All right. Yeah, my glasses aren't clean at all either. I got major gobs on the screen. All right, so remove an index. So let's go ahead and draw ourselves a picture. Real quick, let's just make sure that added index is working correctly. So we have add front, so 7 gets added in front of the 5, add n, so we should have 7, 5, 3, remove front, should we remove the 7, we should be left with 5, 3, let's just make sure that's the case. There's our 5, 3, okay, so now let's say added index, ll.add@index, and the value we're going to add is going to be a 7. And let's go ahead and add that in index 0 for no good reason. So now we have a 7 at the front. So now let's add it at index 1. So now we should have a 5, 7, 3. There's 5. Index 1. So are we adding it after index 1 right now? So before I did this, I just want to make sure this is working first. So this is our current list, 5, 3, so this is 0, this is 1. And when I added 7, I want 7 to become the new 1, right? So it should be 5, 7, 3, at least that was the intention. Okay, so we need to look at why that's not working. It's probably a decision we made last time. All right, so in order to add 7 to bucket 1, we need to first traverse to the element right before bucket 1, right? So let's go into our linked list here. So added index, we're going to take in the 7, we're going to take in the position 1. If index is less than 0 or greater than count, we're going to give them a screaming error saying some bad stuff happened. Else if index is 0, we're going to add front. Else if index is equal to this.count. This is where we got caught right there. Right? I tried to add it at bucket 1, which actually was, actually, hold on. Index is equal to this.count. This.count should have been 2. Index was 1. We shouldn't have gotten in there. Let me just make sure that that's the case. Real quick. Put a breakpoint in. We want to make sure we fail this guy right here. Jump it. Okay, we did. All right, so we failed it. So now we're in the else. So we'll just keep walking through this guy here. So we'll go ahead and we're going to move to the pause right before index. So start I off at 0, keep going as long as I is less than index. All right, so what are we going to do? We should go through here just one time, right? So I start off at 0, index is 1, so is 0 less than 1? Yes, it is. Is 1 less than 1? No, it's not. So we should see, we just go through here once. There's the one time. Here's the second time. We should fail now. We dropped past it. We did. All right, so now we have our node. We'll go ahead and create our new node 7. And then we're going to say n.setNextNode to kernode.getNextNode. Well, what is kernode? Let's look at kernode here. Here's kernode, and this guy has a payload of 3. So we're going to say n.setNextNode to kernode.getNextNode, which is null. Oh. But it isn't the last one. No, we're adding at bucket 1 with a list that has 2. Right now it is adding to the end. So it's this loop right here. My feeling is, let me test something here real quick. I bet you that if I have a 3 list before it starts and try to add at bucket 0, 1, 2. No, it's still adding it to 2. All right, so let's walk this then. All right, added index, we're right in here. So we're going to start cur node off at the beginning. So we're at bucket 0. Keep going as we're less than. Oh, that is the problem. I want to move to the pause right before index. This is going to actually get me all the way to index.
Yeah. So minus.
So I actually need to say -1 here. So that should put the 7 at bucket 1. 0, 1. All right, let's make sure we don't break anything else then. 7's at 1, 7's at 0, 7's at 2. At the end, I think we decided that would throw an exception. Yep. Got added index out of bounds. Okay. So seems to work.
Yeah.
Yeah, our comment told us what to do. I think we were running out of time at the end of last class. We were probably rushing that because I have to remember going afterwards to show you GitHub.
Yeah.
Okay, so now let's do RemoveAtIndex. So let's go back to our keynote here, and let's look at this guy here. This was our picture that we were kind of working with. So let's say that our list currently looks like this. Okay, our list currently looks like this, and we're going to say, okay, well, we want to remove, well, if we remove at index 0, we're going to do remove front, right? If we remove at index count -1, we're going to remove end, all right? If the number is greater than that or less than that, we're going to throw the exception. Okay, let's handle all those clear-cut cases. Then we'll do the middleman, right? Because the middleman's the harder part. So go back into linked list. We're going to do a public void. Actually, it's a public. Do we have it return nodes or ints? Ints. Public int remove at index. And we're going to take in an int index. And this guy's going to throw an exception. Well, to remove it, we don't need val, right? All right, so we'll ask if, well, here we can actually ask this exact same question, right? Just steal that guy. So if index is less than 0, or index is greater than or equal to the count. Okay, for this one, it's got to be equal to, because removing position count is not a legal position. It's count -1 that is the last legal position. Okay, so if they try to give us an index that's either too small or not a legal position in the list, we're going to give them an error. So remove at index. Index out of bounds will give them the index. Okay, so that's our, you screwed up, you gave me a bad value. All right. Okay. Got important stuff. My fantasy football team, somebody has proposed a trade with me. I had a really rough week this week in fantasy football. My team is very Packer-centric, and the Packers didn't play football this week, or last week for that matter. No, they didn't play last week, and they really didn't play this week. Did you watch the game Sunday? That was not a game. 2 undefeated teams. It was like a huge game. Packers versus Denver Broncos. 2 undefeated teams. Packers were favorited. Just got destroyed.
So you lied. You say you like Packers.
When I have homework, no.
You didn't even follow it? So you don't really like the Packers. So like you own a Packers hat is what you're really saying.
I have a cheesecake.
You have a cheesecake? You mean a cheese head? It's like, I have cheesecake. All right. But I always get torn with games like that because part of me, I want the Packers to win, but also I kind of like watching the human misery the next day when the Packers because it was like a demoralizing loss. They lost to a good team, but they didn't play a good game. I mean, they got their butts kicked. It wasn't. Yeah.
Denver, right?
Yeah. Well, I don't care. Losing to Denver is not an embarrassment. Denver's a good team. Okay, but losing to Denver that badly is an embarrassment. But I like watching the sad Packer fans the next day. They're all depressed and their heads are drooped. I just watch the human. It's like the whole city has a cold. It's really funny. I just find it hilarious.
You're not looking like a human. You just want to observe a human.
I know. I love it. All right. So if they give us an illegal position, we'll go ahead and yell at them. Else if index is equal to 0, we will return this dot remove front. Right? If I'm still here, I know they've given me a real number, a number that works. If they gave me a 0, why should I reinvent the wheel? I already have a remove front, so let's call remove front. Okay? Else if index is equivalent to this dot count minus 1, that is, if they want to remove the last legal bucket, we'll go ahead and return this dot remove end. Else, they want to remove something in the middle. Okay. All right, so this is where we make our money, right in here in this little else statement, right? Those first 3 things, even though it's looks like several lines of code, this is the easy stuff. You give me a bad number, I'm going to yell at you. You give me the first number, I'll just use something I already built. You give me the last number, I'll use something else I already built. Okay, now I got to write something new here. This is where else comes in. All right, so now let's go and let's design this. So something else, as you guys were writing your homework assignment, out of curiosity. So all of you said that you took a bunch of time and stuff like that. Did everybody get it working? Anybody not get it working? Run into some struggles? So eventually, through lots and lots of hours, you eventually persevered. It's the punchline. Okay, so that's good. That's good. You spent the time on it doing it. How many of you drew pictures while you were working on it? Like this kind of stuff?
I did.
You did?
Pencil and paper,
Yeah. Well, yeah, whether you do it on here, write it by hand, or something like that, you have to draw pictures. You absolutely have to draw pictures, especially when we're dealing with the pointer stuff. I talked about it last time. How many of you spent a lot of time chasing down a bug that turned out to be something stupid? Usually pictures help with that kind of stuff. All right? And also, I know I didn't show it to you last time. At least I don't think I did. But now, did any of you know how to use the debugger before tonight?
I think the last class you told us.
Yeah, I probably did use it in 535. Yeah.
I think you told us, so that is the last time. I mean, the first time I used the debug tool in Java.
Was in 535?
Yeah.
Okay. That's also a good tool. There's kind of maybe a couple schools of thought on the debuggers. Historically, on smaller projects, I won't use the debugger. Smaller projects, I'll usually do print statements and stuff like that. Almost just kind of do my own version of debugging. But as projects get bigger and bigger like this, where we have a lot of kind of stuff connected, the debugger is a pretty powerful tool where we can just throw a breakpoint in there real quick and say, show me everything at this point in time, right? So I encourage you to use that. A powerful tool, and it's a skill set. So getting used to using the debugger and using it to figure out your problems in your code is something you're going to get better and better at as you use that tool, okay? Just like solving a lot of problems, you're going to get better and better and better at solving problems. You'll make less mistakes and things like that. So it kind of all goes hand in hand. The more problems you solve, the less often you'll need the debugger, right? The more often you use the debugger, the more confidence you'll have in your code, the faster you'll be able to solve problems, rinse, lather, repeat, right? And at the end, you'll be able to solve that stuff even faster than I can. So that's the goal, right? The goal.
I guess that won't happen.
Huh?
I guess that won't happen.
You already said I'm old.
Until I still think I even cannot chase your back.
So But that's kind of the goal, right? I didn't just start programming a couple of weeks ago. I've been doing this for a little bit. All right, so the idea is that with that practice, you then become the go-to person at work, whether it's programming or whether it's your specialty in the IT stuff. You might be the server backup guy or something like that. Anything that you end up doing, you want to get really good at it, so you're not just this fallback person. Okay, and that's something we talked a little bit about last time as well, especially if your plan is to end up working in the United States. Like it or not, you're automatically going to be treated as a second-class citizen, right? You're international students. It's not fair. It's not nice, but it's true, right? So you got to do everything you can to set yourself apart. All right, because I'll tell you what. I teach a lot of undergrad classes, and we're turning out some real idiots. Okay, so don't let them get jobs over you. Show them that you know what you're doing, right? All right. So we need to go ahead and write our RemoveAtIndex. So we already handled this position. We already handled this position. Okay. Now it's the tricky stuff in the middle, right? Okay. So this is 0, 1, 2. So let's say we're removing at index 2. Index is equal to 2. Okay. And pay attention here that I just finished lecturing you on the fact that I want you to draw pictures. Notice that I always draw pictures. And I don't only draw pictures for you guys. Okay? One of the reasons that I don't make that many errors is because I'm very used to solving problems by drawing pictures. Okay? Some things have gotten committed to memory or uncommitted to memory or whatever it is, but okay, I do this stuff even when other people aren't around. Okay? So this isn't just for your benefit. I want you to try to mimic that. Okay? So we're going to try to remove an index 2. That's this guy here. So in order to remove an index 2, what do we effectively need to do? Well, we need to get to index 2 because we need to have control over this lever right here, right? Okay, we need to get that guy gone. Okay, we also need to get to index 1, this guy, because we need to have control over this lever, okay, to get this guy gone. Okay, so we really need to get 2 separate pointers. We need to get 1 to here, that is the index -1, and we need to get 1 to here, which is index. Okay, and we know both of those things will exist, correct? If I'm in this else, I know that my index is at least a 1, right? So that means that index -1 exists, that's bucket 0, and we know that index exists. Fair enough? Okay. So I don't need to ask all those questions. It's kind of one of the nice things about using tools that we already wrote. Okay, since we took away the huge error, and then we said, we'll let the other guys handle the beginning and end. Now we just have to handle the meat in the middle. So now we can operate inside of this else with certain assumptions. We know that both of those positions exist. So let's go ahead and just zip up to those positions, okay? And just for the sake of sanity, and this is going to be something similar to what I asked earlier, we could certainly do this in 2 if statement, in 2 for loops, or in 1 for loop, but why don't we just do it in 2? Okay. Better to be correct with more code than incorrect with less. All right, so let's go ahead and get pause before. We'll start this guy off at 0. We'll say for int I is equal to 0, I is less than index -1, I plus plus, and this is not in pause before. This is node pause before, and this is not going to start off at 0. This is going to start off at head. All right, and what are we going to do? We're going to say pause before is equal to pause before dot get next node. Okay. So this will move. So if index was 1, okay, if index was 1, this guy's going to go from 0 to 1 minus 1, which is 0. I won't go through it all, which means that pause before would be head. We're already in the right place. Otherwise, it'll go the position right beforehand. All right. I'm going to steal this code. We'll fix it here in a second, but we're going to steal it just to be clear. So we'll call this actual pause. Start that off at head. We'll go all the way up to index, and we'll say actual pause is equal to actual pause dot get next node. Okay, without having any more logic applied to this, can we feel confident that both of these chunks of code move our nodes into the correct place? Sure. I mean, it's going to be easy enough to fix this. I mean, what is actual pause actually? Actual pause is actually pause before dot get next node, right?
Yeah.
You know, so we could just dump that for loop there. Okay, but who cares? Who cares if I save 3 lines of code and a couple of microseconds of logic? Nobody's going to be impressed if you are the guy with the shortest program that doesn't work. Make sense?
Yeah.
So as you're doing your homework assignments and as you get out there and you start your professional career and start doing this stuff, always focus on solving the problems correctly first. Then see if you notice a better way of solving it. Then ask yourself, is it worth it? Okay? It works. It works right now. I threw 9 layers of duct tape. This thing's going to hold. Okay? Unless somebody else is going to really care about it, don't spend any more time fixing that when you could go and fix the harder problem. You could spend that extra 20 minutes you would have spent fixing this, fixing that harder problem that actually does need your attention. All right, so again, this becomes an industry thing. Time is money. We've heard that a bunch of times. That doesn't mean you do a bad job, but don't spend extra time doing a good job when you've already done a good job. Make sense? Okay, correct is correct. Most of the time, that's good enough. Every now and then, you'll get to a problem that needs to be higher performance. And in those situations, that's where you're going to take all that time that you've banked up by not wasting your time doing extra crap in the past, and you're going to put it into solving the problem in front of you, right? Now, somewhere in there, though, there's that line in the sand between you want to do something right, okay? Not just correct. You also want to take pride in your work. So you want to make sure you're doing, you're writing code, or you're doing an IT job or a backup or something. You want to make sure you're being thorough and well documenting it and all this other stuff. So somewhere in there, there's a dividing line where you have to decide based on your current position and based on the job you've been asked to do, what is the right thing to do. Okay, so you can't just by default say, well, I've already done an accurate solution, this is good enough, because maybe your boss won't think that. Or, you say, well, I really want this to be a whole lot better, or a whole lot cleaner or something like that, so I'm going to spend an extra 4 hours on this to make it look perfect. Maybe your boss won't like that either, right? Because maybe your boss just wants it done. So don't treat the management of your project as a second thought. The management of your project is just as important as the solution. And that's why people get paid big bucks to be project managers. And make sure you engineer your solutions before you actually implement the solution. Okay? All right, so we'll move into those 2 positions. So we have these 2 guys. Pause before is going to be the pause before. Actual pause is going to be the actual pause. What do we do with those dudes? Well, let's go back to our picture. Okay, so now I have pause before. So draw this guy in here. Here's pause before. And he's pointing right here. Oop. We have pause after. Well, no, we have actual pause, right? And he's pointing right here. Okay? So we've got those 2 guys. This is the dude we want to remove. We want to remove actual pause. Okay? So what's the first thing we do? We need to set pause before's next node equal to actual pauses next node. Make sense? So we're going to say pause before dot set next node to actual pos dot, ooh, that's weird, dot get next node. So that just did this. See how much easier that was looking at a picture? So we have it drawn like this. What are we going to do? We're going to set pos before's next node equal to actual pos get next node.
Is it because remove it easier than add?
Oh, maybe a little bit. But both of them would be tough without drawing pictures.
That is true.
Then we're going to say actual pos dot set next node
Because now,
to null. Okay. So now we have effectively removed those guys. And then what am I going to do? Well, I am removing something. So what I should be removing is actual pos dot get payload, because I've advertised and I'm actually going to return the int. I'll return actual pos dot get payload. Make sense? So let's go ahead and test this guy real quick. So right now we have 573. Let's go ahead and let's do a ll dot remove at index. We'll test the 0 real quick. So this should just give us a 7.3 as our output. Then let's do the let's do a 2. Okay, that's off the end. Let's do a 1. 5, 7. 0. Well, hold on. Let me back up here for a second. 5, 7, 3. So this is 0, this is 1, this is 2. So if I say remove at bucket 2, remove at bucket 2 should remove this 3 here.
but there's exception.
All right, well, let's go look at our logic here. So if it is greater than or equal to count,
Is it because you add as index forgot about the adding count?
it is absolutely that. So the issue here is inside of added index. Was it below it? Yeah, added index. Add front takes care of doing count plus plus. Add in takes care of doing count plus plus. But we didn't actually do this dot count plus plus when we actually had to add it in the middle. All right, so we are in better shape now. So there's our 5, 7. Okay, because we removed at index 2. Index 3 should give us an error. Index 1 should remove in the middle. So there's the 5, 3. Let's remove this guy real quick. I just want to see what the list looked like before that. So this is 5, 7, 3. If we remove an index 1, we should be left with 5, 3. Okay? Make sense? All right, so now we have a method now called display. And display shows the entire linked list, correct? What if I wanted a method called display in reverse that shows the list backwards?
Is it hard?
So, the issue is right now we have a linear linked list where each node points to the next node, right? On and on and on and on. Display in reverse is a little bit tough. If I have 5 elements, what am I doing? I'm going to
Create a new one.
show the 4th, then show the 3rd, then show the 2nd, show the 1st,
It makes it
I have to keep running all the way to the end of the list to display something, then run one short of that to show something, then run just one short of that to show something, so on and so forth, right? Okay, so Blade suggested I could do something, right? You said I could build a brand new list.
Yeah.
Okay, build a brand new list by continually removing things from the end of this one and adding them to the end of the other one, and then display that one,
That
right?
works,
And then put it back, and then put everything else back. Okay, certainly could do that. Let's go ahead and write that real quick. So we can create a linked list. Temp is equal to a new linked list. And then we can say while head is not equal to null. What are we going to do? We're going to go ahead and say temp dot. So we want to remove from the end of the first one and add to the end of the second one, right? So temp dot add end. All right, yep. This dot remove end. Okay, and this guy possibly throws an exception, so we'll just go ahead and throw exception there to keep this simple. Then we're going to go ahead and say temp dot display. All right, now we need to actually go and put it all back. Okay, so let's just make sure it does it in reverse first of all before we go and fix it. All right, so let's go to the remove from index thing here. Okay, so right now we should have 573. So I want to do 375. So we'll say ll.display in reverse. And there's our 375. Okay, fair enough. Except we just broke the original.
Yeah.
Right? LL is no. Okay, if I do ll.display here, okay, we get a beautiful empty list right there. Okay, because we emptied the other one out completely. Okay, so just last minute before we take a break here, let's put everything back. So what do I need to do? I need to remove from the front and add to the end. All right, so count. This is a fun little trick because even though count is private says it's only accessible inside of the class name linked list. I happen to be inside the class name linked list right now. So I actually do have access to the other guy's count. Okay, directly without a getter. Okay, oh. So we're going to go ahead and copy it all back. So we're going to say this dot add end from temp dot remove front. Okay. 573, 375. Did we miss one guy? Oh, hold on. Let me just check something here real quick. Oh, add an index, that's fine. Just real quick, let's just do this. All right, so showing the count down there, 375. So there's our temp display right there. And let's take out this last LL display just for right now. All right. So this guy currently looks like this, then this. So then what are we going to do? We're going to walk through this list, which has 3 things in it. We're going to remove from the front, and we're going to add to the end of the original. Okay. Actually, we're going to remove from the front and add to the front. Remove it from the front here, add it to the front here, remove from the front here, add it to the front here, remove to the front here, add to the front here. We want to remove front, add front. Remove. Put the other guy back in. All right, so we're getting the 7. Remove here, we're adding the 7, so we're not actually getting the 5. And why is that? We saw that the count was 3 here. We remove front, that's 3. So removing front from the 1 list does not seem to be working. So let's look at what remove front does.
Oh, by the way, I think for the count it's changes all the time. It's because
Yeah. Yeah, the issue is that we're operating on the variable count.
Maybe should while.
We have a loop here
Yeah.
operating on the variable count. So we should probably say while
Or you have a new.
while temp.count is greater than 0. Do this. So as long as there's still stuff inside of temp, keep doing this. So the issue is that we had a for loop based on count, but count kept changing. So we weren't going through it enough times. So this just says keep taking stuff from temp until temp doesn't have stuff to take. Make sense? All right, so we're going to say that this is a good complete version of linked list for right now. So let's go ahead and take about a 2-minute break.
If you can keep that quick.
Okay. All right, so let's take about 15 minutes. We'll come back at 8:20, and then we'll go from there.